Hello, 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 hello. Welcome to High Entropy. So yeah, let me see once more, one time, like whether it's working or not. Let me see if my face is visible. Okay, you can see my beautiful face. So let's begin. Let's begin. Let's begin. Where is it? First of all, welcome to High Entropy, and it's day 17 of what we say, not what we say. Basically, iLearning, and I'm just about to start a stream, and I hope you can hear me. Oh, it's time to sleep now, bro. How can you sleep? So, first thing, what I'm going to do? Just about to start a stream, and I hope you can. Wow, now I are. Hi, hi guys. Oh, welcome to hi. Actually, it's not. My behavior is not matching with this channel name. I have to be spontaneous, high energetic, and all. So, welcome to I'm dropping. Let's begin. Let's begin. Hi guys. Welcome to hi. Do let me know if you have any suggestion or recommendation. So yeah, just let me know. Okay. Now I will show you my Discord where no one has joined. Please join, guys. I'm expecting someone to join. Please join my Discord server and we'll talk there. I never use Discord, that's why I wanted to use. By the way, so what is today's plan? What is the agenda for the day? Accelerator, let's use it. I will tell you. Okay. Oh, I was working on it. What when I did when I created it. Okay, this is MCP server, and there is host, there is client. So new. If they will give you the login option, then it will be better. Where is the option? Bro, I want to create another one. Let's you. This is. I will use something. AI learning day 17. So what is the plan for the day? It's big. So we have so far what we covered or what I learned. Actually, I'm feeling like I learned the tools or I learned different things. For example, first learn Langchain. Okay, let me note down what we learned so far. Langchain. Okay, so this is Langchain, and here we learned first thing was chat LLM call. Second, we learned template prompt. Third, we learned MCP calling. Though he already taught it, so I'm just referring it. Fourth, we learned chains, very important. Fifth, we learned parallel chains. Okay. Sixth, we learned conditional chain. Here we were using. Here what we were using. Chains were normally chains with custom function, not custom function. I hope I like to. You can say these are the things that we learned so far. But as under, it's not sufficient for me. I feel like okay, this and there is one more topic conditional. We what is branches we can say Runnable branch, or what is branch runnable? Something was there. The parallel, runnable parallel. I think it was the same name, right? Integrity. Come on. Runnable parallel. Wow, perfect, bro. So it will be runnable branch, runnable, and you can see the name they have kept as per the standards. Camel case. Runnable parallel. What is this? Okay. Runnable parallel, and custom function will be runnable lambda. You can actually it's they kept the name very intuitive. Like if you know one, you can remember another. So we learned so far. Okay, what I'm planning further. Next goal is maybe AI dating. I will start Langgraph, but before that I want to master it, right? Langgraph. So I won't jump into. I want to build some project, not day 18. Next, next I will say. Yeah, I think it's good, but not right approach. I'm just exploring if there are some some courses or what. So searched. I want to build projects. Then only I'll get the clear picture of Langchain. I just know only few things. Okay, how to create chains, how to run them. But if it's like what I feel right now, like something, how to. It's like you know different parts of a body, but you don't know the complete body. No, no, it's not correct example. I will just give you one example. Example, let's say you know different parts of computer, right? You know different parts of computer, but don't know how to assemble and build computer. So I feel the same. So it's not enough sufficient. So that's why I'm planning first. I will master it. I will learn and I will build some projects. Yeah, very important. If I won't build project, it's like you are learning things. And also I want to build few MCP servers so that I already built one for this one Sakai result, but I got the basic concepts, but still there are a lot of things. It's not like the over how to use gateway and all things. Yeah, if you'll get hands on, then I feel like I will be confident, and it's pretty important. See, like people are creating hugging face. Okay, yeah, I need to like to use the open source Langchain, Langgraph I'm planning. After that, I will explore Hugging Face. So let me note down it here in my notes first. I'm not learning first, I'm correcting the things. Langgraph projects, I will say projects before it, and then Hugging Face, not hugging, Hugging Face. So I just looking for something AI engineer agentic track. The complete isn't an MCP course, bro. I just want. Look, he created 2.5 hours video and build a real world project. Are you going to narrate me, or I don't know why people create some such. Definitely in 2.5 hours, how can you build? You'll build some puppet project. or some dummy project maybe, or a small project. I don't know, and I don't want to say anything, but it feels like, let me watch the video first. I will get, don't just book by cover, for sure. Download slides.
By the end of this course, you will build two production grade RAG pipelines, one that uses company data and another one that powers e-commerce semantic search engine. This is Bharat Tippi Reddy. I'm a software
Hey
architect
Bharat.
and best-selling instructor. Over the last decade, I have helped developers master Java, Python, DevOps, and GenAI tools while working on hands-on projects. And developer
Tell
is
me what.
course builder and code on your machines. It will then implement a vectorization pipeline by loading different types of documents, splitting them into chunks, and ingesting them into your. We'll see why we need vector indexes, understand different
Great, bro.
caching.
I want some fancy projects that I can write down, or I can showcase on my. At least I can get some idea how to build things. I watched his videos like on Flutter in the past. So Krishna completed his NTKI bootcamp with Langgraph and Langchain. 45 hours course, bro. Based on, you cannot decide like based on the length, but I know this guy creates a lot of beautiful courses. Let me watch what exactly it's gonna do in this project. Pydantic he covered.
Hi everyone. Welcome to the Agentic AI and Generative AI Bootcamp with Langgraph and Langchain. I am Krish Naik and I will be your instructor throughout this exciting journey into the world of AI agents and cutting edge generative AI applications. In this course, you will not only understand the theoretical concepts behind agentic AI, but also gain hands on experience by building real world application using the most in demand tools like Langchain, LangGraph, Langsmith, OpenAI, Grok, Olama, and many more. We will start by setting up your development environments with Anaconda and VS Code and get you started with essential tools like Pydantic and Python. You will then dive into Langchain with a practical project based approach, learning how to interact with models like OpenAI and Olama and build foundation LLM application using LCEL. As we progress,
Hey, what
you
is
will learn to
LCEL?
build AI agents with memory and conversation history, explore the differences between traditional agents and agentic system, and start building your own autonomous workflows. A major part of this course is focused on LangGraph, where you will not only understand its core concepts and components, but also implement advanced workflows, integrate human in the loop mechanism, and build RAG
Hmm.
based applications. You will also
Sounds
learn to
promising.
debug your application efficiently using Langsmith, ensuring your projects are production ready. Whether you are a data scientist, AI engineers, or someone deeply passionate about building intelligent application with GenAI, this course is structured to take you from beginner to the expert level with hands on code walkthroughs, real world use cases, and system design best practices. So, what are you waiting for? Go ahead and enroll now, and I will see you all in the class. Thank you.
I will buy it, but not now. Bro, what if I'll watch within 30 days and I'll ask for full refund? 2 days left. So this is course. This is the one course I'm gonna watch or I'm gonna purchase. And is there any other course? Ultimate Rag Bootcamp. Actually, I want to. Bro, why are you creating agentic AI bootcamp with LangGraph, Langchain, Ultimate Rag Bootcamps using Langchain? Build powerful rag pipelines. Traditional advanced multimodal agentic AI, Langchain, LangGraph. Some of the parts are going to be common in between these things, but I need to grasp a lot of things. I'm just going through. So I'm collecting some information.
Hi everyone, my name is Krish Naik, and I have more than 15 plus years of experience in Enter and
Okay.
someone who has spent amazing Udemy course building right now. From powering intelligent chatbots to
Oh,
creating
they are detecting like I'm
multi-agent
sharing my
AI
screen.
system that reason, adapt, and self-improve, RAG is the backbone of many advanced AI applications. In this course, we start from zero, learning traditional RAG pipelines and moving step by step into cutting-edge techniques like advanced chunking, hybrid search, multimodal RAG for text, images, and more, multi-agent RAG for collaborative reasoning, persistent memory for context retention, self-RAG and adaptive retrieval strategies, corrective and autonomous RAG pipelines. By the end of this particular boot camp, you will not just know RAG, you will be able to design, build, and deploy end-to-end RAG system that solves real-world problems with the latest framework like Langchain, LangGraph, and Langsmith. Whether you are a beginner in AI development or an experienced engineer looking to the next level. So what
Da, 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 da. Okay, by the way, it's further. I will forget it. I need to for the time being. I just want to before I finish the. Bro, everyone is just telling me some YouTube. Oh, bro, in the picture you are looking too young, and in the photo your hairs turned gray. Build a reg agent in Python. Okay, let me do one thing. What should I? Let me do one thing. Don't jump directly into that part. There was an interesting part of it, right? Langchain, bro, where are you? Let me finish it
This
first.
word, this keyword, whatever you want to say, it's called React. Let's talk about it because it is one of the most popular keyword, one of the most popular jargon we use in the agentic AI and AI retention world. It is called React. Now, this word is not React, bro. This is React. See, this is not like React.
Reasoning
This
and
is
act.
React. What does it mean? React is actually made up of two words: reasoning and then acting. Reasoning plus
Acting.
acting. Basically, it is reasoning plus evaluation plus acting or reasoning plus observation plus acting, but this is the high level definition. So let me show you React agent. React agent full form. Yeah, reasoning plus acting. Yeah, that's it. Like that is the you can say core of everything. Reasoning plus acting. There's a middle thing as well, which is called evaluation or observation. But I will just explain you everything step by step. Now just sit back and relax because you need to enjoy this thing because this is very important. Because once you understand the React architecture, boom, you understood almost everything. Really, yes. You would have already understood certain things, but this is amazing. This is the hottest part of the entire thing. React. So let's say you want to build an agent. Okay. Let's say you want to build an agent. Okay, let's build an agent. Let's say you want to build a React agent. Because everyone is just trying to say, I want to build React agent, I want to build React agent, I want to build React agent. Now, how to build React agent, why to build React agent? So we know that React means reasoning plus acting. Okay. Now, you know what? What does it mean? Let's say there is Rahul. Bro, come here. So let's say this is Rahul. This Rahul wants to build an agent. Okay. So that whenever there is a user
Where's the
who sends
where are
some
the
input,
eyes of Rahul?
that's what users do, right? Input. Okay. Makes sense. This user will send the input. Okay. Yes. Now you know what? Now currently we are using really high level and advanced agents, LLMs provided by OpenAI, which are amazing. Which are actually answering all of those things that it knows, right? But there are some questions that LLM does not know. Oh, really? What are those questions? LLM knows everything. Let me show you. If I ask LLM this question, let me just bring the code. Conditional chains, and this is my code. So let me just ask this simple question. LLM OpenAI, which is the best model, one of the best models that we have in the market. Okay. Dot invoke. I will say, hey, what's my name? Simple question. Let me run this. Let's see what it says. I do not know your name. Would you like me to call you? If you want, tell me now. I will use it for this chat. Simple. So it does not know my name. I don't know why, but yeah, it doesn't know my name. So what does it mean? That means LLMs are not trained on your personal data. LLMs are not trained on your organization's data. LLMs are not trained on data that it doesn't have access to. Only you have access. So what to do in that scenario? For example, let's say you have a database, you have a data warehouse in your organization, and you want to talk to that database. You want to just, let's say, make some API calls, right? Let's say you want to just you
Like
have a
pipeline we built for
Postgres database and you
that,
can just use Cyclops
table argument,
library to connect to it, and you just want to set up
augmentation,
it as a result. Or let's say you have data warehouse and AWS and Azure, you can use the API calls to get the data. Make sense? Like you can just do that, and you know how to build those Python functions. Yes, but how LLM will do that? Because LLM doesn't have access to do that, and how it will do? Then in that scenario, we simply create something called as tools. What do we create? Tools. So let's say we have some tools. Let's say we have a tool for our Postgres. Let's say, right? Or let me just use Postgres. Perfect. So I have this function, Postgres database, that can access this Postgres. Okay. Then let's say I also have access to email, right? Because obviously I cannot send an email to me. Let me show you. If I say send an email to anshlamba blah blah.com. .com? Yeah.
at gmail.com.
gmail.com. Right? Let me just write this. Is it actually sending an email? See, I can't send email directly, but I can draft you one copy. See, it cannot send the actual email. It cannot. So what does it mean? That means it doesn't have the capability to send an email. Let's say it also wants to do something with your, let's say, code. It doesn't have access to do that. It can answer your questions, but it doesn't have the capability to perform these things. Then who can perform these things? Who has the access and who has the capability to do all of these things? You. Okay, so should we become
It
LLM?
has
No,
brain,
I
but
can say that.
not
You don't need to become an
muscles.
LLM. Now you need to create the tools. You need to create the functions for these things. One function for this. One function for this. One function for this. Okay. Okay. These are the functions. Okay. These are the functions. Perfect. Perfect. And you will create something called as tools, or basically toolkit. These are tools. Tools are what? Functions, right? So when I combine all of these things, what it will become? Toolkit, right? This is my toolkit. Where we have all the tools written. This is my toolkit. Make sense? Anything fancy we have discussed? Nothing. So simple. So simple. Perfect. So now I have this toolkit. Do you know what will happen now? This thing, this LLM will connect to this toolkit. Okay? To this toolkit. And it can make use of these functions. Really? Yes. It can talk to these tools in the backend. Wow. Now what we did? We actually increased the power of our LLM. And this step is called tool binding. This is what? Tool binding. We basically bind our LLM with the tools. That's why it is called tool binding. Okay? Okay, makes sense. Tool binding, right? Do you know what will happen now? Now, my input, if this input can be answered directly by LLM, it will simply give the response. Take it like this. It will simply say, hey, you want the response? Okay, let me just give you the response, and this is the response. Take it like this. Simple, right? But when this LLM doesn't have this capability to do that work, it will look for its tools. It will look for its toolkit and will search for the relevant tool. Hey, let me just check. Do I have that tool to perform that action? This user has asked me to send an email. Do I have that tool? Let me just first of all check it. It will simply search for that particular toolkit. Right? It will search for that toolkit. Now, that tool from that toolkit will be used if that can do the work. Let's say this email tool is here. So what will happen? It will simply go to its toolkit. Okay? Go to its toolkit to search for the tool. Let's say this toolkit has got the response. Now you know what will happen. This tool will not send the answer directly back to the user. No. This will give the response back to the React agent. Okay? Like this. This will be a
Then
loop.
it will provide.
So what did I say?
to
This
the
React agent will
tool.
search for the tool. It will make the use of the tool. The output of the tool will go back to the LLM. Basically, the React agent that we are building. Underworld is just an LLM, right? So this will go back to the LLM. It will observe it. Hey, this tool has generated this output. Is it good enough to go ahead, or should I just make another tool call? Let's say this email tool has done the work and has not actually completed the work. It needs to make another tool call. It will again go back to the toolkit and will search for the task that is pending. Then it will bring that tool, and then it will just give the response back, and then it will just observe it. This step is called evaluation. This step is called basically you can say reasoning, or basically observation. So that is why it is reasoning plus acting. That means it will first of all call it. It will take action. Then it will just do the reasoning part as well. It will also observe the output. Once LLM is satisfied that I have the final answer, only then it will generate the output. Only then. And if it is not satisfied with the output, it will not generate the output, and it will keep on searching for the tools. Yes, that is the entire concept of React. And this is the kind of agent that everyone tries to build nowadays, because it's a kind of autonomous agent. Because you have the tools, you just create a wide range of tools, let's say a long list of tools, and your React agent can actually do everything. But you need to understand all the ins and outs of this thing, because this is not very easy to understand. Let me be very honest. Yes, I will show you the code to implement this thing, first of all, so that you can actually see what is going on, how the things are going. Then I will be breaking down each and everything, like how it is doing everything behind the scenes. Because in Langchain, you do not see behind the scenes. No, you do not see it. If you know like the things in detail, in depth, then obviously you can see it. By default, it will not tell you how it is doing that. I will just show you how it does that behind the scenes, and why it is very useful, because then you can just customize this agent as well for your own use case. And again, for the interview, it is like very handy, very helpful. I hope it makes sense. I will also show you tool binding. I will also show you how it is working. Makes sense? Okay, let's see. First of all, the code implementation, which is given in the documentation as well, which is the first step. Then we want to team. Okay. So now let's just try to write the code, and I can also show you the documentation. Let's see. React agent Langchain. And you know what? There are so many tools available in the Langchain as well. So you don't need to create tools from scratch. There are tools such as Wikipedia search. There are tools such as called DuckDuckGo search. If you just want to search for news, latest news, there are so many search. There's like Tably search, which from which you can just make some search. Like you can just use Tably as a search engine. So there are so many integrated tools as well. I will use 2 to 3, and then you can just explore along. Okay. React agent Langchain. Okay. Where is that documentation? I think documentation. Let's try to explore on our own. Langchain and agents. Maybe here. Okay, so here they have just updated this thing. Earlier it was called as create a React agent, but now they have just created a new function, new class, whatever, from Langchain.agent, import create React agent. So now you just create like this, create agent and tools. See, simple, simple. Did you understand that? You simply define the model that you want to use, and you want to just add the tools that you want to attach to that, and that's it. And everything will be done on its own. See, simple. But yes, you need to create the tools on your own. And obviously, you need to define the tools. How LLM would know like what tools it needs to just use or create, right? And there are some dynamic models as well, which I'm not a big fan of it, because if you just want to make a tweak, I would rather stick with my own code to make some tweaks instead of using their decorator, because they can just make changes to their code base anytime and they'll simply say, hey, we have a new update available, we have this V1 available, and yes, your code base will be broken. I cannot just make my own decorators, bro. You do not need your decorators. So that's why I do not use these decorators and all. If I want to make any tweaks, if I just want to make my agent dynamic, I will just write my own code and I will just make it. And yeah, that's me. Okay, so let's try to see what are the tools. Let me just click on tools, and here are the tools that we have. And yes, we can use a tool decorator. This is something which is stable. We can just use this. Okay, and yeah, I like using this tool definition. And there are so many tools. First of all, I just told you that you can create your own customized tool. So this is a definition for that. If let's say you want to store something with your database, right? And you can just simply do it. If you want to use integrated tools, let me just see if they can just show you the integrated tools. Integrated tools. No, they have not shown here. I can just search. Let me first close all these tabs. So I will simply say DuckDuckGo search Langchain, because that is like one of the tools. See, so here we have, oh yeah, I think they have just moved the thing to integrations. Perfect. So if I just go to integrations, I will see all of these tools. See, popular providers. I have tools for OpenAI, Google, Anthropic, AWS, Google, Hugging Face, Chroma, Pinecone. These are by the vector databases. And Databricks and Mistral. All of these things are here. Redis, Elasticsearch, and all providers. Then we have everything here. These are the, you can say, the ones which are validated. And there are some community providers as well. If I just open this one, I will see a long list of all the things. See all providers, click here, and then you will see all of the providers here. See, wow, such a big list of tools that you can just create. These are all of the, you can say, tool integrations, whatever they have created. DuckDuckGo search, DuckDB, like so many things. 11 labs, wow. So you have so many things. So let's try to start with anything. We can also use IBM, Jaguar, wow. So many things, wow man. They have actually added so many things. You can also explore on your own. See, Tably is also there. Tably is basically the search engine that is very popular. And then we have, wow, so many things. We have Twitter as well, wow. So now let's try to apply this thing. React intro, okay. So this is our import thing. Perfect. So now what we want to do, first of all, we will create our tools, right? Let's create our tools because that is the base. Okay. Let's create our tools. And normally we'll be just creating some amazing tools. Okay. So first of all, let's create the tool number 1. And this will be like a news search, because let's say your user wants to get some news, right? So we can just have that tool. And what is the basis of the news search tool? It is called DuckDuckGo search. And I can just show you DuckDuckGo search. It's here. So if you want to use DuckDuckGo search, it is free. That's the best thing. You do not even need any kind of API key, because with some other search or new search tools, you need some API keys, but it is completely free. So how can you just use this tool? This is first of all very integrated. DuckDuckGo search is actually a standalone service that you can just go to their website and you can just see how you can just use it. Look at the code, like how to make an API call. You do not need to even write this Python function like this, because that's how you just make API calls, right? Because we are simply making the API calls to the function. But here we have Langchain integration, and we can simply use this function DuckDuckGo search run, which is created by Langchain. Okay, so what I will do, I will simply copy this, and I can simply go here from Langchain community.tools, import DuckDuckGo search run, and this is an instance for that. Okay, let's say search tool, it makes more sense. And I'll simply say Obama's first name. So what it will do, it will make that tool call, or let's say I want to search the news. Who is Anshul? Let's see if it knows. Search no module in Langchain community. Yes, we need to install this module, which is called Langchain community. So I will say this one. Do we have virtual environment? I think they should add this feature where you can automatically enable the virtual environment. I'm writing this again and again. Activate. UV add and then Langchain community. Perfect. Now let's wait. Perfect. So now let me just rerun this. dd dax python please install the pip install. Udd dax. What do you mean? Could not import ddgs Python package. Please install it with. Okay. There would be something. Maybe DuckDuckGo search. So simply say uv pip install ddgs. Let's add it as well. Because it is saying that. So let's do that. Ooh, it knows, man. Okay. That's good. Good. Okay. So what it has done. This is not generated by AI. This is a tool call. That means I made a tool call to DuckDuckGo search run. Okay. And I simply wrote this thing.
Bro, it knows because you already kept your profile on the internet. That's why. And mostly they prefer to get data from especially from the LinkedIn.
Basically, news. I want to get some information regarding this question. Who is Anshul? So this answer is the response of this particular function called DuckDuckGo search run. This is not generated by LLM. This is not generated by LLM. Yes, we will bind this tool to LLM so that it can make the use of this function, but currently it is not connected to LLM. This is simply the response we are getting from the DuckDuckGo search. Make sense? Perfect. Makes sense. Simple, simple, simple. Okay. So this is our tool. Let me just hide it. It's fine because why to show off? So search tool, one tool is done. Let's say I want to add one more tool, and it will be which tool you should use, because we have very long list, and I'm a big fan of this tools list. If you can even go to integration and tools and toolkits, you will get so much. So you have Google search. See, these are the paid ones, these are the free ones. So you can actually compare what you want to use for search, for code, for productivity. You have like so many things: database, finance, integration. And let's try to use one tool for let's say we have Gmail toolkit as well. Nice. Let's use for Wikipedia. Let's use Wikipedia. Wikipedia. Here's Wikipedia here. Let's use Wikipedia. Okay. So what I will do, I will copy this and I will Wikipedia search tool. I will write this and then I can simply go to this wrapper because we want to run this, and let's write this. So this is like Wikipedia tool. I can say Wikipedia tool. This is search tool. Make sense? Okay. So now we just want to test it same way we tested this. People install Wikipedia. Okay, let's install Wikipedia. Not a big deal. Perfect. Now let me just run this. Now let me just test it. Wikipedia tool dot invoke. Let's say what is the capital of France? It should know, right? Because this is Wikipedia. Wikipedia knows everything. Page closed. See, what is this thing? You are actually getting everything. Because when you just make a call to Wikipedia tool, you are actually getting the response of the entire Wikipedia, right? So this is that thing. That's why you're simply seeing everything. So you're seeing France, but before France, you are also seeing this garbage stuff as well. Closed-ended question, contrast, open-minded question. So this is like the response that you get whenever you're visiting the page, the Wikipedia web page. You will see all of these things, right? So that's exactly the returning. So do not keep that. That's how it works. That's why we need to connect these things to LLM so that LLM can prune these things, right? Okay, makes sense. So these are the two tools that we have created. Let me also create one custom tool so that you will also learn how to create custom tools. So let's say you want to create one tool which will do something that it can also not do. Like we don't have any kind of integration with that particular function that you want to build, right? So you can create a custom function as well. Tool 3, and I want to make it as custom enterprise tool. Let's say that tool is just for my enterprise, like where let's say you are working, right? So I'll simply say from Langchain
tools
import tool. Okay. Now I will create a decorator tool, and then I will write let's say enterprise tool. Make sense? Makes sense. So now what I will do, I will simply create a function, and what this function does, this simply sends an email. We have integrations as well for email. I'm just like demonstrating it with a hypothetical situation where we do not have the let's say integration with email, right? So what I will do, I will simply say return, and I will say email sent. Let's say email sent. Obviously, I need to write a code here to send the email, and for that you will need to create these APIs as well from Mailgun and maybe Gmail API. We are not creating those APIs right now, but you know how to create all those basic stuff like API and then just making the calls. You can just write your code here. Now, very important thing: whenever you are creating your custom function, you need to add a doc string. Why? Legends are asking what is a doc string. Okay, good. Doc string is nothing but a kind of way to add comments in your function. You write like this: 3 double quotes, and then you simply write a description. You simply add a kind of message so that LLM can read. Because just tell me one thing. You have created this tool, right? You have created this tool. You are creating this tool. LLM will pick one tool, two tool. It needs to pick that tool on the basis of a, you can say, a kind of message, right? How LLM will decide. So in that particular thing, you have to just tell, okay, this is the information. This tool is built for this purpose. This tool is built for this purpose, like this. Okay. So we have to write a description. So that's why I think we can even write description here as well, because that makes sense. Description, I will simply say, this is a tool to search Wikipedia. And I can also write maybe go search here. Description is a tool to search the web for news, let's say. And I can just complete this. This is a tool to send emails to employees. Very good. Email send. Let me just run this. So that's how we can add that description. Obviously, these are the integrated functions. So we do not have like power to add the doc string within this, but I'm so sure when Langchain would have integrated these functions, it would have already added the doc string because they know like you're very lazy, you will not write doc strings. But you should always try to add it, right? So now this is the information. Now these are the tools that we have created. Simple. Okay. Now at least add a toolkit. Basically, let's create a toolkit. Now this is our toolkit, and in this toolkit we'll simply write all the function names that we have. So we have first of all search tool, and we have then Wikipedia tool. Perfect. And then we have enterprise tool. See how well this particular IDE is picking the context. It is written here enterprise tool. It is suggesting me email sender tool. Bro, which model are you using in the backend? I want to know. Okay, now enterprise tool. Let me just run this toolkit. So now I have the toolkit of these 3 tools. If I want to see the names of these toolkits, I can also write like this: toolkit dot get tools. I think this was the function. I don't know if it is available now. List as no attribute get tools.
It's normal
Makes
list.
sense. I think this is a list. So actually, we can actually write like this: toolkit directly. Yeah. So now we have these two, like these tools. Let's go search, Wikipedia query on, structured tool. Basically, name equals to enterprise tool because this is the kind of tool that we have created. So that is why it is coming like this. Makes sense. So now we have created these toolkits, and it looks good. Let me just add this code here. So now let's create our agent because now we're good to go. Perfect. Agent, basically React agent. React agent. Perfect. In order to create the React agent, you already know the code that we have just seen in the documentation. It is very simple, straightforward code, just few lines of code. Earlier it used to be a little bit bigger, but now they have just simplified it. So I can just make some changes. I want to use GPT-5 mini and tools equals to toolkit. Perfect. Now let's try to show the agent. Now let's run this. Okay, so this is my agent. Wow. You know what? They have just started visualizing this in the V1. It was not available before. We had zero visibility. we had zero visibility over agent that we were creating before. So now you know what is this? This is a kind of mermaid. Mermaid. It is called mermaid code. So whenever it is like doing this thing, we can actually see the backend code as well. But I don't want to show you that code because you will not understand anything in that backend code. No one can understand it. It's basically a way of designing all of these user tags. And in LangGraph, we just can show you as well, and then we can just visualize it as well. It is in the backend, but I have realized after exploring V1, they have literally rewritten everything in LangGraph. I'm so sure. Like under the hood, LangGraph is running. I'm so sure because this kind of thing we built in LangGraph. But yeah, it's fine. So this is our agent. Now you can see that this is the model, right? Because this is the model name. And what is the model? Model is this one. This is the one. We can also say LLM. It's not big deal. I can also say model equals to LLM. LLM OpenAI that we have, right? I can even run this. Kya OpenAI? Object has no attribute lower. What do you mean? Did we create LLM OpenAI? Yeah, we have this LLM OpenAI. Oh, I see. Okay. Makes sense. We have to use this name as this because remember our init chat model thing where we have to define the model itself. So we cannot say LLM OpenAI like this because this is not the model variable. This is the model itself that they are calling. Okay, that's fine. That's fine. So now this is the model. Okay, and these are the tools. Is it similar to this one? Yes, obviously. Obviously. This is exactly, I know like this looks better, but yeah, this is exactly the same thing. Because this is the model and these are tool calls. This start and end is just a way to tell that this graph is starting and ending. Make sense? This graph is starting and ending. Okay, now I will just show you very good thing. So now let's test this agent that we have built. Now I want to invoke the agent, but I will invoke it using streaming. Now what is streaming? So you are data engineer, you should know about streaming. Streaming means when we just display or basically use the data as soon as it arrives, right? So when I will be just making this model call, there will be so many things running in the backend, right? In the background. And we want to also visualize this. We also want to see what are the things going on in the background. So we'll be using streaming so that we can see everything what's going on. And it's a good way to actually understand the thing as well. So let me just show you React agent invoke with streams. Okay, very good. Okay, so now I can bring that streaming code. It is also written in the documentation, I guess. Where is stream? App tool call. Okay. Begin quick start. System prompt. Because I use streaming with LangGraph. I don't use it with Langchain. Okay. Where is that? I saw it somewhere. I saw it. I don't know where, but I saw it. Oh yeah, here it is. It was under secret distributed. Because I know like I saw it. So let me just copy this and let me just paste it here. So what is the thing? I am simply trying to make a model call. Okay, and I want to write my questions. What I will do, I will simply say, who or let's say, give me the latest news about let's say stock market. That's a good question. So you know what will happen? Let me just first run this. So you message, this is my message, give me the latest news that I have sent to the AI. Now it will go to the tool call. Just wait. You will see everything. Just wait. It is running in the real time. See. Now again. Let's wait because it is generating more messages. Okay. Tool message. Okay. More tool messages. Wow. Okay. Let's wait because we just simply posted a very generic message and it is just making more and more tool calls. Now that is done. Now let me just show you what happened. First of all, let me click here score element so that you can see all of the outputs. So first of all, we made a. Like we asked, give me the latest news about stock market. Perfect. This is my message. It went to the model. Yes, simple. Remember the flow. It went to the model. React agent. Okay. Our React agent that we have created. So now, then what happened? React agent, basically LLM, didn't have the built-in function to search for the news because LLM is not trained on news, right? Or it cannot be because you need news like latest news, maybe today's news. So now it looked for any tool in its inventory, in its toolkit, and it found a tool. How? Because you provide the description, right? So now we found the tool called DuckDuckGo search. Simple. It used that tool called DuckDuckGo search and it called that tool. And this is the call ID. And these are the arguments. Stock market news January 8, 2026 because today's January 8. See, I'm literally getting today's news. US S&P 500 Dow, Nasdaq latest, blah 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 blah. Then this tool, this AI message didn't generate anything. This tool, basically AI message, generated a tool call and that's it. With arguments. Okay, with arguments. And remember this because this concept is really important. You need to understand everything. So AI message, that means AI message means message is coming from LLM. So LLM did not generate a response. It generated a tool call. It generated an indication that I want to make a tool call, bro. Please allow me to make a tool call. Makes sense? Then it made a tool call because we have provided those tools. This is the answer that my tool has returned. This is not generated by LLM. This is the message that my tool has returned. Basically, DuckDuckGo search has returned. Perfect. Now it went to AI message again. It got the data. AI message was not satisfied. It made another tool call. It said, give me more news. Now it got this message. Then the AI message said, like, give me more data. It gave its query with obviously some changes because it wanted to make some more calls. Then it got the value back from the function. Then AI message again made a tool call and then again tool message gave its the data. Makes sense? And then finally AI message has returned the data, like returned the answer at the end. This is the flow. The point why I'm explaining this thing because I will just show the backend as well, like how it is running in the background. LLM never generates the answer. It simply indicates that I want to make a tool call. If it needs to make a tool call, it will make a tool call.
I'm feeling sleepy, bro. I need to. People are studying very much hard. You know what I'll do? I will put my little water on my eyes, so you will see I'm crying. Okay. Because I don't want to go out. See, I'm crying, guys. Fuck. Actually, I'm seeing, trying to get motivation when I'm streaming. I'm not crying, guys. I'm not the kind of person who cry. Hey, hey, hey. Subscriber mode, so I cannot comment here. By the way, समय रहना. I want to build project, bro. So I want to. So that I can. I already told you, like, I'm just trying to first. First thing is like top to bottom. So I don't want to deep dive before I just get the flavor of it. I mean, just little bit more about, because everyone is giving. So I'm very dumb. They created video 1 year back, and now I'm learning this. Bro, are you sleeping? Why are you not? I think it's live stream or what?
As an end to end. Okay, so this is the idea.
What is the idea?
But it was like a little bit older implementation. So there are many things has been updated, and because of that, there are many people actually they're having issue with the setup. So they requested me personally, sir. I'm not able to execute your medical chatbot project because Pinecone is giving this kinds of error. Okay, so how we can resolve that? Because if you see the Pinecone environment, so they have updated their like code base. Okay, so right now, let's say if you want to.
Actually, I think I'm rushing too much. Let me go through the tutorial. Pine cone and blah blah. I don't know. Then how I'll do? I need to learn a lot of other things. So better I will stick to one thing at a time. Otherwise, fucked up. Everything will be crazy.
It will get the response back. Says whether it wanted to make some more calls. Then it got the value back from the function. Then AI must see whether it will. Because I know, like I saw it. So let me just copy this and let me just paste it here. So what is the thing? I am simply trying to make a model call. Okay, and I want to write my questions. What I will do, I will simply say, who, or let's say, give me the latest news about, let's say, stock market. That's a good question. So you know what will happen. Let me just first run this. So you want message, this is my message, give me the latest news that I have sent to the AI. Now it will go to the tool call. Just wait. So let me copy. So yeah, here it is. We can actually see the backend code as well, but I don't want to show you that code because you will not understand anything in that backend code. Nobody can understand it. It's basically a way of designing all of these user tags. And in Langchain, we just can list. So actually, you can actually write like this toolkit directly. Yeah. So now we have these two, like these tools. Let's say go search, Wikipedia query on, structured tool. Basically, name equals to enterprise tool because this is the kind of tool that we have created. So that is why it is coming like this. Makes sense. So now we have created these toolkits and it looks good. It looks good. Let me just add this code here. So now let's create our agent because now we're able to go. Perfect. Agent, basically React agent. React agent. Okay. In order to create the React agent, you already know the code that we have just seen in the documentation. It is very simple, straightforward code, just few lines of code. Earlier it used to be a little bit bigger, but now they have just simplified it. So I can just make some changes. I want to use GPT-5 mini and tools equals to toolkit. Perfect. Now let's try to split the code. We had zero visibility. We had zero visibility of our agent that we were creating before. So now you know what is this? This is a kind of mermaid. Mermaid. It is called mermaid code. So whatever it is like doing this thing, we can actually see the backend code as well, but I don't want to show you that code because you will not understand anything in that.
Mermaid. Mermaid means it's like a fish like this, yeah. When I'm reading this description, I thought, what the heck are you talking? Mermaid is an open source JavaScript based diagramming and charting software that generates diagram from text based description. Okay. Okay. Hello. Hi. How are you?
Backend code, no one can understand it. It's basically a way of designing all of these, you can say, tags. And in Langra, we just can show you as well, and then we can just visualize it as well. If it is the backend, but I have realized after exploring V1, they have literally rewritten everything in Langra. I'm so sure. Like under the hood, Langra is running. I'm so sure because this kind of thing we did in Langra. But yeah, it's fine. So this is our agent. Now you can see that this is the model, right? Because this is the model name. And what is the model? Model is this one. This is the one. We can also see LLM. It's not big. I can also say model equals to LLM. LLM OpenAI that we have, right? I can even run this. Yeah, OpenAI object has no attribute lower. What do you mean? Did we create LLM OpenAI? Yeah, we have this LLM OpenAI. Oh, I see. Okay. Makes sense. We have to use this name as this because remember our init chat model thing where we have to define the model itself, so we cannot say LLM OpenAI like this because this is not a model variable. This is a model itself that they're calling. Okay, that's fine. That's fine. So now this is the model. Okay, and these are the tools. Is it similar to this one? Yes, obviously. Obviously. This is exactly, I know like this looks better, but yeah, this is exactly the same thing. Because this is the model and these are toolbars. This start and end is just a way to tell that this graph is starting and ending.
Oh,
Makes sense? This graph is starting and
I
ending.
thought
Okay,
they are
now I will
using
show you
sort
very
of
good thing.
in-
So now let's test this agent that we have built. Now I want to invoke the agent, but I will invoke it using streaming. Now what is streaming? So you are data engineer, you should know about streaming. Streaming means when we just display or basically user data as soon as it arrives, right? So when I will be just making this model call, there will be so many things running in the backend, right? In the background. And we want to also visualize this. We also want to see what are the things going on in the background. So we'll be using streaming so that we can see everything what's going on. And it's a good way to actually understand the thing as well. So let me just show you React agent invoke with streams. Okay, very good. Perfect. So now I can bring that streaming code. It is also written in the documentation, I guess. Where is stream? App tool call. Okay. Maybe the quick start. System prompt. Because I use streaming with Langra. I don't use it with Langchain. Okay. Wait, that I saw it somewhere. I saw it. I don't know where, but I saw it.
search it though directly in
Oh
the.
yeah, here it is. It was under secret evaluation. Because I know, like I saw it. So let me just copy this and let me just paste it here. So what is this thing? I am simply trying to make a model call. Okay, and I want to write my questions. What I will do, I will simply say, who or let's say, give me the latest news about let's say stock market. We'll go to the tool call. Just wait. Let me just first of all run this. So your message, this is my message. Give me the latest news that I have sent to the AI. Now it will go to the tool call. Just wait. You will see everything. Just wait. It is running in the real time. See. Now again. Let's wait because it is generating more messages. Okay. Tool message. Okay. More tool messages. Wow. Okay. Let's wait because we just simply posted a very generic message and it is just making more and more tools. And now it's done. Now let me show you what happened. First of all, let me click here, scroll a little bit so that you can see all of the outputs. So first of all, we made a. We asked Uri, give me the latest news about stock market. Perfect. This is my message. It went to the model. Yes, simple. Remember the flow? It went to the model. React agent. Okay. Our React agent that we have created. So now, then what happened? React agent, basically LLM, didn't have the built-in function to search for the news because LLM is not trained on news, right? Or it cannot be because you need news like latest news, maybe today's news. So now it looked for any tool in its inventory, in its toolkit, and it found a tool. How? Because you provide the description, right? So now we found a tool called DuckDuckGo search. Simple. It used that tool called DuckDuckGo search and it called that tool. And this is the call ID. And these are the arguments. Stock market news January 8, 2026. Because today is January 8. See, I'm literally getting today's news. US S&P 500 low, Nasdaq latest, blah. Then this tool, this AI message didn't generate anything. This tool, basically AI message, generated a tool call and that's it. With arguments. Okay, with arguments. And remember this concept is very important. You need to understand this. So AI message, that means AI message means message is coming from LLM. So LLM did not generate a response, it generated a tool call. It generated an indication that I want to make a tool call, bro. Please allow me to make a tool call. Make sense? Then it made a tool call because we have provided those tools. This is the answer that my tool has returned. This is not generated by LLM. This is a message that my tool has returned. Basically, the Pego search has returned. Perfect. Now it went to AI message again. It got the data. AI message was not satisfied. It made another tool call. It said, give me more news. Now it got this message. Then the AI message said, give me more data. It gave it query with obviously some changes because it wanted to make some more calls. Then it got the value back from the function. Then AI message again made a tool call, and then again tool message gave it the data. Makes sense? And then finally AI message has returned the data, like returned the answer at the end. This is the flow. The point why I'm explaining this thing because I will just show you the backend as well, like how it is running in the background. LLM never generates the answer. It simply indicates that I want to make a tool call. If it needs to make a tool call, it will make a tool call. It will get the response back, and then it will generate the response. If it does not need to make a tool call, it will not do it. So all of these things are actually managed by Langchain. Actually, everything is managed by Langchain. Under the hood, how it is possible to do it? So basically, under the hood, what do? We simply first of all create an LLM. We bind the tools manually. Here, Langchain has done that part for us. First step, tool binding. Very good. After binding the tools, we basically make the call to model, right? Then we need to define this logic. These two arrows, these are not very simple. We need to build this logic. We will simply say, if in the response we have something called as, let's say, tool call. I will just show you. If it is written, make a tool call. Then at that time, I will call that function. How? Because I have the information for the tool call name, basically call ID, plus its argument. Because LLM is smart enough to generate the arguments. It will say, bro, you can make this tool call, and the tool call will require this argument. I can do that for you, but I cannot make a tool call. You will make a tool call, and you will just run the function, and you will give me this on that. Who is you? Who? LLM is you. It is talking to himself or herself or itself. Make sense? That's how it works. That's how it works under the hood. Okay. Now, if I just show you very good example of like tool calling like under the hood, let me just show you that. If I want to bind my own model, because currently we didn't bind the model, right? Bind the LLM. We didn't bind the LLM. Let me show you manually binding the LLM. So currently, LLM with tools. And once you grab this concept, bro, I would say just go in and just build something simple. So manually binding the LLM with tools. So currently, if I use my traditional LLM OpenAI, right? If I say LLM.invoke and if I just ask the same thing, what's the latest news? What's the latest news about the stock market? Maybe it will just give me the news which is like outdated because it was trained like long way back, but it will not do anything. But let's see the result and then I can just continue with that because I can otherwise give the other prompt for which like it will not have access to do that at all. Maybe send an email or whatever. So let's wait. See, I don't have internet access. Perfect. So it cannot do that, right? Now it can show the magic. So this is the without binding. Perfect. Now let me just write with binding. Perfect. Now with binding, what will happen? I will simply say LLM bind it, and I will bind my LLM with tools. LLM OpenAI dot bind tools. Perfect. And what are the tools? Basically toolkit. Makes sense? Now what will happen? First of all, let me just run this. Perfect. Now if I ask the same question from it, bind it. Let me just ask this question. Let's see what will happen. Perfect. Now you know what will happen. Like what actually happened. AI message didn't say I can't fetch live news or blah blah blah. It has returned empty content because it didn't generate anything. But just scroll towards right. Just scroll towards right, and you will see something called as
Tool message.
scroll towards right. Right. See, tool calls. LLM is saying, yes, I cannot generate anything, but I can make a tool call. So it has listed the tool it wants to use for the tool call that is called binding the model with the tools. Langchain does it automatically for us, and you will say, like, how are you doing this? This is the code. This is writing this code for you. Okay, so it uses this thing, and you can also see it has generated the arguments. See, arguments query, because we're using query, you can say input. I can also show you. If I go here in my DuckDuckGo search, here's the DuckDuckGo search. DuckDuckGo search. Okay, so this is like the function, so it knows that it will be query, so it's fine. And then it is saying stock market news today has generated a phrase that will use. Perfect. Makes sense? And see, it has created multiple instances of it. Now this time again, same tool but with different argument. Because it can have like multiple, you can say those phrases. So earlier it said like latest news today, then S&P 500 today, then it will be like one more, see, Dow Jones, industrial, whatever. So it has actually created 3 different phrases. So it called the model 3 times, and you know how it happened. You know, it knows this thing. So LLM returned this thing. So let me show you. So LLM returned this tool call. Right? Now, what we do manually, like Langchain is doing everything for you, but what we do manually, we take this list of tools, because it can have only one tool or it can have like a list of tools as well. We take this list of tools and we make the function call one by one. And we keep on updating that particular response with the message type called tool message. That's why you are seeing a new type of message called tool message. See, tool message. We do it manually. We do it in LangGraph. But in Langchain, that's why like Langchain is a lightweight, you can say AI agent builder. Because you do not manage it anything. Everything is like done for you. From the agentic point of view, not from the branching. Branching is like fine with Langchain. But for agentic standpoint. I hope it makes sense. why I'm putting this much of effort for this topic? Because when I was also learning, I was so confused. And I wish I had this kind of explanation in front of me. And in just one video, I would have felt so good. But I'm still so grateful for all the resources that I also got. So it's fine. It's fine. It's fine. It's fine. Right? Because every resource is good. Because I would say each resource or every resource will teach you something. It will not like give you something which is not useful. It will still give you something useful. So still grateful for all the resources that I have used. So amazing. So now I hope it makes sense. Right? Now let's try to build a quick one more example, and it will be like very handy and very useful for data engineers. Because I want to build that. It will be fun. So let's end this video with that example. And then I will at the end give you a very important thing to just cover, and it's called RAG. I know you're waiting for that thing, don't worry. I will also tell you what to cover in RAG and how to cover RAG. Because RAG is actually a totally different area. And you need to go much deeper in RAG as an independent topic. But don't worry, I will just tell you how to cover that as well, because there is a good news. I have a dedicated course on RAG as well. But let's cover this, let's complete this example first of all. It will hardly take 10 to 15 more minutes. And then we're going to sum up, and then we can just talk about RAG as well quickly. And then I will just guide you to the best resource for RAG. Simple, if you just want to learn from me, obviously. Make sense? Okay. This RAG is actually different. It's totally different as an independent topic. It has nothing to do with any framework. RAG is RAG. Like RAG is totally different. Okay. So let's create second and React DB agent. Let's try to create an agent for our SQL database. Let's try to do this. It will be fun. So now you'll be saying, from where we can just get the database, bro. Is this a question? Is this a question? You don't have a database? I know you would have a database, but let's say that database is in the other machine and you do not want to download any server again, and you don't even have a Docker installed. So let's quickly create a lightweight database. It's called SQLite. If you are not familiar with SQLite, it's very simple. SQLite is a kind of serverless database that you can run, and it stores everything within the files, within the storage, and you do not need any kind of server. It is a lightweight database, not like should not be good for scaling, and it's just for POC, and we are good with that. So let's create a file to init database, right? And for that I don't need to install SQLite. It is not installed already. SQLite was not found. What do you mean? In package history depends on SQLite.
Maybe SQLite 3.
What is this? Python version, the solution created for the Python version modified project. While active Python version 3.12. Okay. The resolution created for the Python version is modified by this. Let's go to Python. If you want to add Python regardless, get resolution provide the frozen flag. Why do I need to provide frozen flag? Let me support it. SQLite 3. That's becoming the whole code. Let me just comment it out. Everything. Let me just run only this thing. Import thing. Let's see if it is working fine or not. Yeah, it is working fine. Okay. We don't need your import. I think it would have already imported it. So okay, that's good.
Maybe there is dependency.
So now what we need to do, we will create a database. So in order to create a SQLite database, it is very simple to create a database. If you have a database here in the folder, it can connect to it, and currently we do not have. So it will create a database for us as well. So let's create it. And yeah, so I'll simply say connection equals SQLite3.connect. And if you are familiar with MySQL or psycopg2, it is exactly the same. So in that thing, we simply write psycopg2.connect, and then we just pass all the things host, db, whatever password and all. Same with MySQL, it is SQLite3.connect. So now you say how to connect with this, because we don't have any database, we don't have any password, we don't have anything. So it is called the locational database, where our database is located. It is located in the current directory. I'll simply say I will say mydb. Okay, mydb. Or let's say sales DB, just to make it more professional. Sales DB, and then I want to store it inside. Let them orders. Let's sales.database. Sales.db. Okay. And let's create a folder called sales DB in the chapter 3. Sales DB. DB. Okay. So let me run this. And so what it will do? Let me show you. So it will throw the error box. What's wrong with you, bro? Unable to open database file. So you see this. You need to create this file. SQL3.connect. Sales DB. This is funny, right? Yes. Okay. Sales DB. I think I know the issue. Like, there's no issue. So currently, this file is running from this folder, Langchain tutorial, and we want to run this from this folder. So I'll simply say cd, and I can also add the system path from here. It's not a big deal. So I can also say import os, and then os.directly if it is there, but we already have a folder. So we can also say system.os.sys, or let me just import sys as well. Import sys, and once we have the sys, we can simply add it to the system path. So now what will happen? Now it will add our, you can say, system path to this directory. So now let's try to run it. If not, you can just run it from here. And it should add it. OS system.path. Just print it first of all. Like what is the directory? Print this thing. Okay, Langchain tutorial, chapter 3, init.py. That makes sense. Okay, so it is just returning the same thing. Let me just try running it from the CD. Because I know it happens when we just use or run this thing via this debug button. Because this is not a good way to run Python. We should always run like run Python, something like that. So let me just remove it or keep it. It doesn't make sense. So let me say CD. And then chapter 3. And then we want to go inside sales DB. Not sales DB. I think chapter 3 is fine. Now if I say Python init db.py. Perfect. Now if you check the sales DB, it would have created the sales.dbc. Perfect. Because it creates the sales.db automatically. Makes sense? If I write con equals to this, and if I just run Python, it will create this. See? Sales.db. I know the database is empty for now, but database is created. Simple. And now I can just rerun the cell as many times as we can, because this will not throw in here. This will not. Why? Because file is there. Oh, okay. Makes sense. Because now, like it usually either creates the database if it doesn't exist, and if it exists, it simply connects to it. So let's create a cursor quickly. Cursor equals con.cursor. And here I can simply say con.cursor, which is this one, connection is this one. And now I can create a table quickly. And I'll simply say cursor.execute, create table, ID, customer name, product name, quantity, price total, perfect. I want to create this table. And I also want to say cursor.execute, and it's insert some data. insert into orders, and values will be this. Just write the values as well, bro. Bro,
Yeah,
you can
it's
just do this thing as well,
working.
or you can just run a loop. But for now, we're simply running it for the demo purpose. So let's run it like this. Okay, this is one way of doing it. You can also say with not open, basically cursor as like cursor, and then you can just simply use the context manager to do it. Like there's multiple ways to do that. I only like this thing, cursor execute. If you just want to use context manager, you can just do that as well, like this with cursor as cursor and cursor execute. What is the benefit of it? All things will be done within this context. It is called context manager. Okay, I can even run this as well, like this. So the moment we are writing anything outside this, the context is over. We don't need to worry about anything. Make sense? Okay, so now let's say, let me just make it here. Okay, with this here, and I can say cursor dot commit and connection dot close. Okay, so now let me just run this again. Cursor, it does not support the context manager pro. Oh man, this doesn't support because there is SQLite. Because I have used it with Postgres and MySQL, it works fine. But SQLite doesn't support it because SQLite is like very lightweight. So let me just remove it and just follow the traditional approach. So nothing to do with it. So what can do with it if it is not allowed? So let me just run it now. Okay, it has run it successfully. Now this sales.db has some data. Now we'll say how do we know? I can show you. I can just simply create a demo file just for you. I will simply say demo.py. And I will simply say import SQLite. I will create a connection with this one, and I will say select history from orders and let's see what does it return. Okay. Let me just show you, bro. Perfect. And this one. Do I kind of open that thing now? Oh man. Let me write CD. Wow. It is saying no, this thing exists.
Bro, right click.
Oh man, let me just open the new
on
one.
open.
Amazing product, man. Amazing product. Amazing product. So I will simply say title demo.py. Perfect. It does not support the context manager, bro. Okay, we forgot, bro. Perfect. Let me just run this. Perfect. See, I can see the data. That means data is there. Wow. That's how we read the data. So now we have database ready. Your tension, your stress is over now because I have created the database for you. You do not need to download any server. So we have the database ready. Now what we are trying to do here, we want to create an agent which will take care of our SQL things. Can we do that? Yes. It will automatically run everything and it will give the you can see data to us. So as you can see, we have 3 records. 1, 2, 3 because we ran it I think 2 times, so that's why it is returning like this. Let me just clear it and let me just run it just to see the response. We have 3 response. Okay. So we have laptop, tablet, and smartphone, right? So maybe I just want to take the order for tablet. Right? Maybe I want to check it. Or maybe I want to just check how many sales we made for smartphone. I want to just see you are creating an agent for any manager and you are a data engineer, you have created this particular data warehouse. Now you need to build an AI agent as well for your database. Right? So now what you will do, you will get a SQL agent and you will build SQL agent so easily with Langchain. Literally, man, you do not need to run any kind of those things. It will already like run everything on your sandbox, and it is very good. Let me show you. If I can just find the documentation, this is the one SQL database toolkit. So they have created a special tool for SQL workloads. But yes, you need to be very, very cautious to implement it in production because you need to add some guardrails so that no one can inject some query which can harm your database, and also you need to take care of those things. And it is kind of common sense you need to do that. But let's say we are good with that, and let's actually try to build this. Okay. So our DB is done. So first of all, I can just create this DB. What is this DB? This DB is nothing but a kind of, you can say, connection that you need to create. So first of all, I will write this thing SQL database agent. Perfect. And I can just close this and let me just write it here. Wow. Let's wait for it. Okay, so this is done. So now what we will do, we'll simply create an agent which will run the query as well, because there are 2 types of agents. One is like who creates the query, the second one is who just runs the query as well. Because we want to create the runs the query as well, because we don't need to just generate the query. Okay, so let's first of all create a database, and we have a special function called SQL database, which is this one, and we don't need to even create cursor or basically the connection. So everything will be done by Langchain. So how we just create a database connection? If you read the documentation, you will feel a little bit confused, but do not worry, you do not need to create this connection at all. You simply need to use this particular thing, SQL database, and that's it. Because you already have the engine. Okay, makes sense. So you simply need to say SQL database like this. SQL database, or let's say DB, whatever you want to say, let's say SQL DB equals SQL database from you, right? And then you simply need to pass the URL. And the URL is like this, SQLite. And we do not have the thing dot, and we have, I think, sales DB. Perfect. And within that, we have sales DB dot sales dot DB basically. I think so, yes. Sales DB and sales dot DB, I think it makes sense because we have like same folder in the same, you can say, folder, and then we have a database within that. Okay, so this is our DB that we have created. So far we are good. This thing is done. Now we need to create LLM. Let's quickly create the LLM. Now let's quickly create the LLM, and let me just bring that particular thing, that code, this one. Let me just write it here. So it will create the LLM for us, LLM OpenAI. So now we have both the things. Both the things, yes, LLM and DB. And now we need to create a toolkit like this. Okay. Makes sense? Now we just need to create a toolkit like this. Let me just copy it and let me just paste it here. So now what are we trying to do? We are creating a toolkit. And in this toolkit, we have so many tools related to SQL. Really, yeah. They have built-in toolkit where they have integrated so many tools within the same toolkit. Let me just show you. If you scroll down, if you just write get tools, you will see the entire list of tools. Wow. We have query SQL database, we have info SQL database, we have list SQL database, we have query SQL. So these are the built-in functions that are created by Langchain. You can even create your own functions for DT. What will happen? You will simply get the, you can say, input, then you will pass the database as context, and then you will simply get the query in return, and then you will just run it on sandbox. It's not very something magical. It's just like building a wrapper and making your life easy when simply use the functions. Makes sense. So toolkit is like toolkit, SQL database, and DB equals DB, which is not DB, SQL DB, and LLM is LLM OpenAI. Perfect. Now it makes sense. Perfect. So now what it will do, it will use this database as a context, and it will use this model obviously. Because just tell me one thing. Is anything magical happening here? No. So what is happening here? I will go to LLM with my NLP, with my natural GUI, natural language GUI. Right? I will go to LLM, I will say, hey, generate the SQL GUI. LLM will say,
create
okay, go on,
parameters.
generate the query, but at least tell me the database name, at least tell me the table name, at least tell me the
Arguments,
column name,
parameters.
only then I can create a query. Simple. So you are going to LLM with this database as a context. So when you pass the database as a context, now LLM has the, you can say, context of the entire database. It knows the database name, it knows the columns, it knows the table, everything. Oh, okay. So that's how it generates a query. You're simply passing the context and that's it. Okay, so let's run this. Toolkit is ready, and if I just show you toolkit dot get tools, you will see all of the 4 tools that you have. Perfect. Now we have toolkit as well, we have everything as well. So now how we can just create the agent? So now just skip everything. You simply need to copy this and just paste it here. So we are using Langchain.agent import create agent. Okay. So now this is the function that we use, and we use only and only LLM and toolkit, and we have toolkit. Yeah, we have toolkit table, and I need to use LLM OpenAI. Perfect. So now this is my agent. This is my agent. See, now it has created this agent. Model, tools, and blah, blah, blah. And this tool has all the SQL tools. Make sense? Make sense? Now, do you know what? Now you can literally invoke this agent and you will get the answer. Okay, let's see. Let's see. Okay, I will say agent.invoke. Okay, and I want to say how much sales we made for smartphone. I know the answer. The answer is, if I see the terminal, if I have the real records, for smartphone we made 500, right? What is this 500,000? What are these two columns? Let me just check the agent.py. Let me just remove this. So we have price and total.
Quantity.
Okay. Oh, okay. Price and total. Oh, because we have quantity as well. So total price is 1,000. Okay, 1,000. Let's try to use tablet. It's just very straightforward. 600. Let's use this tablet. How much total sales we made for tablet? It should be 600. If it is using everything right, if it is using right SQL and everything, wow, we have an error. Expected dictionary. How much total sales we made for tablet? Okay. What troubleshooting this is? Expected dictionary. Okay. So we need to use any kind of input by calling it. Let me see. Yes. Okay. Okay. We need user and oh, so messages is the key. See, this is the downside when you use the automated created functions. But no, not really. You can just use this one as well. So if you have got the idea, like what I'm trying to say, how much total sales we made for tablet. So we need to pass the messages key as well. Okay, let's now try to run it. Let's see what happens. Okay. Okay. Very good. Very good. Very good. Yes. 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 It is generating the output. Let me just zoom out a little bit. Perfect. Total sales for tablet equals to 600, and it has already given you the reason as well. 3 units into 200 each. Wow, man, literally amazing. Let me show you what actually happened. So, first of all, I asked this question: how much total sales we made for tablet? Okay, okay. Now it made a tool call to this particular function. It's called SQL DB list tables. We didn't create this function. We didn't create this tool. Langchain created this tool. So what it does, it simply lists down all the tables that we have. Because currently I just asked query related to single table. Maybe I'm asking a query which needs to join multiple tables. So first of all, it will list all the tables and it will give to LLM. Simple. See, list tables are done. Then it figured out that I want to use orders table. LLM is smart enough to identify. Perfect. Now this table information. See, SQL DB schema. That means what is the schema of the orders? Like what are the column names? Oh, so this function actually acted and it gave it the schema name, like all the columns. Then this is the table. Create table orders ID integer and blah blah blah. This is a tool message. And this is the schema that we pass to LLM. Now AI is smart enough to just generate a query and run the generated query against it. Based on the schema. Based on the schema. That is why in the modern applications, we always say that whenever you're creating a table, whenever you're generating the tables, you need to provide some description to each column so that LLM can easily pick the right columns. People are saying LLMs are hallucinating, LLMs are not generating the right results because data quality is poor. Data quality is poor. You need to create tables with right descriptions. In the modern tools and technologies, there are some options where we can just generate the descriptions like this. And it is important because see, I know that there will be some column that says total. So it aligned that particular question with that particular column name. But sometimes we are asking a question which is not very much aligned with the column name. So how will you find it? Using description. Make sense? That's how it works. So see, you have actually built a kind of agent that can create, or basically, and I can also remove it, that can actually write, or it's not just write, you have actually built an agent which can just do anything on a database. Anything. Make sense? Make sense? Make sense? So that's how you just do all of these things. Wow. Literally wow. So it is a kind of agent in itself. Okay. So now let's try to understand the concept of RAG, and then I will just provide you the best resource for that as well. So first of all, let me just provide you that. Then you can just jump on that topic. Let me just say RAG Ansh Lamba. Just search it, and this is the RAG full course that you can just watch. And this is an amazing, beginner friendly. Like this will not expect anything from you in terms of RAG. And this is I think 3.5 hours course. You can simply go there and you will love this course. This is like from zero to pro and actually need it. This is like amazing course. Okay. But yes, let's cover like what exactly the RAG is. Just fundamental, and then you can simply go to this course. Makes sense? Because see, I have just added RAG in this particular course as well. Not a big deal for me. But I know the depth, the fundamental knowledge, the conceptual knowledge, the coding knowledge, the practical knowledge, the implementation knowledge that you will get in this particular 3.5 hours course. Like obviously, it is worth watching this course. So like, let's guide this particular thing and let's provide this amazing masterpiece that you created to my lovely fam. Okay, but still, let me just tell you what exactly the RAG is. Why RAG is so popular. Let's try to cover RAG. Now, RAG actually solves the problem. Okay. What problem? So let's say you have this thing. Okay. Well, let's even remove this thing. Let's say you just have that element. Perfect. Let's bring it here. Okay, perfect. So let's say you just have this thing, LLM, and you are here. Perfect. Now, this LLM doesn't have the access to your data that you already know and that we have validated as well. Let's say you want to ask some questions from a PDF, and that PDF is actually the sales file for your organization. Okay, simple. Now let's tell you one thing. If I want to ask some questions related to that PDF, it can be a PDF, it can be a text file, it can be literally anything. It can be a database as well. Okay, because RAG is not just a tool or just a kind of function. RAG is a concept. RAG means first of all retrieval, augmented
Generation.
retrieval, augmented generation. This is RAG. Okay. Now what happens when LLM doesn't have the access to your data? How it will access your data? The answer is cannot access the data. That is why what we do, we provide a kind of inventory. We provide a kind of folder, we provide a kind of repository from where LLM can access the data. Okay. So let's suppose I wrote this question. How much sales we made? LLM doesn't know this. Let's say you're writing this question from your organization, right? But LLM doesn't know this thing at all. At all. Okay. So now, how LLM will know this? So what I will do, I will attach something called as, let's say, a tool. Let's say this thing. Let's say I provide this particular archive, or let's say my data. My data. Okay. I have provided this. So what I will do, I will simply link these both two things, like this. So now what will happen, whenever I will just asking this question, how much sales we made, or any question, and I know that information is available within this data, LLM can do that. Okay. Is this magic? No. There's a, you can say, logic plus formulas behind it. So what it does, RAG is basically like multi-step process. That's why I'm just suggesting you just watch that video. Okay. But still, I'm just simply giving you very high level knowledge, very high level. So what it does, it stores your data in the form of vectors. Okay, in the form of vectors. Okay. Let's see if we have any more vectors. Oh, let's use this one. Yeah, that makes sense. Okay. This will store your data in the form of vectors. Okay. Let's say vector 1, vector 2, vector 3. Vector 1, vector 2, and vector 3. Let's say this has 3 vectors. Because it totally depends upon the context size you want to pick, right? So it has these 3 things, okay, under the hood. So now what will happen? This LLM will go here. LLM will actually go to this thing. So when it is going to my data, actually it is going to this particular thing. Make sense? So I can change the angle now. So this is the reality of it. Okay, so it is actually talking to this. So what it does, it will convert your question as well in the form of vector. Okay. Interesting. And it is called query vector. Because this is a query. Right? Now this query will go. Now this query will go inside this particular area. And it will find the relevant vector. So this goes inside this. Let's say this. And it found that this query is similar. Or let's say it stays out, but it can just go and check that this particular thing is similar. How does it know this? Because LLM knows it through the formula that it uses. And what kind of formula it uses? It uses something called as cosine similarity. It can be Euclidean distance as well, but normally we are not teaching you statistics. Okay, so don't worry about. So he can just use this thing. So it is not allowing me to just post this. Let me just push it. Because I want to go to this vector at anyhow. Perfect. Bro. Okay, let's do it like this. Okay, perfect. So let's say this query is actually similar to this vector 1. Okay, you know what it will do? It will return this vector 1 like this, back to the LLM. Okay.
And that will
now
be
what will happen?
used as a context.
Now what will happen? This
That is
LLM
known
has
as
this information in the form of vector.
augmentation.
Okay. And then obviously the original text as well. Let's say it has the file associated with it. Let's say any file. Let's say this is the file associated, let's say the CSV or this TXT, any file. Okay. This file, basically data, textual data. Because actually it is in the form of text, right? So this will go to this particular LLM. How? On the basis of similarity. And what formula are we using for similarity? You don't need to know this for now. Right? Like how it is just comparing this query with this vector, how it knows like it is similar to this and not similar to this and this. Basically we achieve this using cosine similarity or Euclidean distance, but you don't need to worry about that. Just imagine that LLM is doing that, all of that stuff for you, like all the similarity search. Right? Okay. And in Langchain as well, we have like dedicated function called similarity search. So we don't need to actually create that function because every you can say vector database has its own particular way to retrieve or compare data. So we can just use Langchain's package, simple. So when we have this information available, now just tell me one thing: can Langchain answer or basically can LLM answer this question? Obviously yes, because it will use this data, right? Now it will answer you back with the right answer basically. Okay. Perfect. That's it. Right answer. Makes sense? That's the concept of RAG. Now why do we call it as retrieval augmented generation? First of all, retrieval. It retrieves a similar vector. Then augmented. Augmented means making something enriched, making something curated. So we augmented our model with this particular text, which was not available to LLM before. And at the end, we generated the data with this context. This is called retrieval augmented generation. This is a high level overview, or you can say high level process of RAG. Complete process. Now, how to store this data, how these vectors are created, how the similarity search is happening, how this augmentation is happening, how generation is happening. you can watch that video that I have created on this channel, and you can even search it on YouTube, tag Anshlama, okay? Or I will also tag the video in the description. If not, you can simply search on YouTube Anshlama tag and you will find that video. I would say that's all for this.
Perfect. So we finished this. Okay. By the way, I'm just watching silently. Pretty bad, bro.
YouTube, tag Anshlama, okay?
Let me note that. Write down. Finished. Langchain. Mm-hmm.
Hello, my name is Krish Naik and welcome to my YouTube channel. So guys, last week I had announced that I will soon start the series with respect to generative AI, considering Langchain in mind, where I will focus on creating a lot of end-to-end projects.
2 years,
so yes,
bro. Reg. No, no. Okay, so I'm confused. Shall I jump to bro? It's okay. I think this way I won't. It won't work. I think I can use Udemy to get more. Why don't I finish laying graph as well? Line graph.
This is a complete 6 hours long agentic AI with LangGraph masterclass, which will make you a pro LangGraph developer, because this will cover the difference between AI agent versus agentic AI, agentic nodes and edges, state schema for stateful orchestration, identity orchestration graphs, conditional nodes in LangGraph, tool binding with LLMs, React agent architecture, prompt chaining, worker orchestrator framework, generator evaluator architecture, adding human in the loop feature in LangGraph, managing memory in LangGraph, and much more. The best part is this course is
hello all, my name is Krish Naik and welcome to my YouTube channel. So guys, today in this particular video, I'm going to discuss about this amazing topic to make you understand the differences between Langchain versus LangGraph. Now, I've been making similar kind of videos from past couple of weeks or from past month. And here our main aim is to make our fundamentals quite stronger. Let's say that if I ask you a question in an interview, when should we probably go ahead and use LangGraph? Or what is the differences between Langchain and LangGraph? What would you probably try to explain? Just write down in the comment section before seeing the specific video. And then after you write down the comment, right, just go through this entire video and then try to see that how many things that I've actually told. Does it matter?
Okay, so let's note down. Excellent draw. Come on, bro. Pretty great. We are learning, right? So, and Langchain. It is not filling. Bro, come on. Hello. What the heck? Langchain versus Lang graph. Good. Very good description. Langchain. Langchain. So why do we need Langchain? I remember when you want to build and orchestrate the agents, or you can say building agentic workflow where multiple agents are working together. For example, we can say example, one agent calling another and then making decision and forwarding accordingly and making progress accordingly. Moving forward accordingly. Okay, so this is one thing. Lang graph, I don't graph. When you want to manage the agents and their memory and all, their memory, context, etc. etc. Graph seem, don't you think, my doubts? I mean, it's not I'm the person who can. Doubts. Actually, a few days back only I read somewhere, I was watching a video where someone said like, I have a doubt. Then she said like she said it's incorrect. If we are then we have to say like, I have a question. Okay, let me use it. So I have a question. Seems like sounds like Lang graph is more about orchestration. Building graphs. Oh, 3. Where are you, bro? Building graphs or DAGs. DAGs, I don't know if it will refer here. Not DAGs. Okay, no problem.
Matches with all the information that you have, right? So please make sure to do that. But in this video, we are going to have a detailed discussion between Langchain versus Langgraph. Trust me, just watch it till the end. You will definitely learn a lot of things. Now, if I talk about Langchain, and I hope it is one of the most popular framework which is basically used to create generative AI application. So first of all, we will just go ahead and talk about Langchain. So let's go ahead and write it down over here, like Langchain. Now, if I talk about Langchain, in Langchain, obviously this Langchain is basically used to create, I probably say it is used to create LLM powered application. LLM powered chatbot assistant. It can be an application or generative AI application. Okay. Now, when I say LLM powered, that basically means anything that you create, whether you create a chatbot, whether you create a simple app, or whether you create any kind of application, right? At the end of the day, you are specifically using LLMs, right? On top of these LLMs, there are multiple things that can be used. Here, you can use prompts along with LLMs. You can use tools. You can use different kinds of integrations and many more things. So overall, if I probably talk about Langchain, any application that is basically developed in Langchain, a generative AI application or an LLM powered application or an AI chatbot assistant, there are three main important steps that happens in Langchain. This is my one step. This is my another step. And this is my third step. Okay. So these are the three main components. Now, what are these specific components? When I say steps, I'm basically talking about components. The first component is nothing but it is basically called as retrieve. Okay. So here we are basically going to write it as retrieve or retriever. Then the second important component is nothing but summarize. And the third important component is nothing but your final answer or output. Okay. Now, when we talk about these components, okay, so here I'll just go ahead and write output. Okay. When we talk about the specific components in Langchain, whether you generate any kind of generative AI application, LLM powered application or AI assistant, these three components will be definitely there. Now the question rises, Krish, what does exactly happen in the retrieve? In retrieve, there are three main important things that we basically do. One is data ingestion. Now the question rises, what is data ingestion? Data ingestion is very simple, right? We ingest a data, right? We probably load a data from a specific source. Now, the main thing is that here the source can be different. It can be a PDF file, it can be an external database, it can be an Excel file, it can be a website. You need to probably web scrap the data. There may be various different ways, right, in data ingestion. So when we talk about data ingestion, this is also called as, we basically use something called as document loader over here, right? So we use nothing but document loader. So in Langchain, you have a specific class where you have a lot of packages and integration specifically with respect to document loader. Here, the main aim is that you try to load documents from different sources. It can be any source. It can be a PDF file, it can be an Excel file, it can be a CSV file, it can even be some third-party APIs like Wikipedia, it can be Archive, it can be anything as such. Right? So there are multiple sources, and Langchain has a huge amount of different kind of integrations already provided in terms of document loader. And what I feel is that whenever you try to develop any of this kind of application, this is the most important step, because here the parsing of the data will happen, right? The parsing of the data will happen. The more when you do the parsing, if you do this much more accurately, then you will definitely be able to generate or create a generative AI application with much more accuracy. So now there are dedicated companies who specifically do this particular task, who create this kind of packages with respect to document loader, right? I create a document loader to, let's say, web scrap the data from the internet, which will be a very important use case for most of the use cases that we specifically implement in the industry. So in document loader, this basically happens, right? And that is a part of data ingestion. Now coming to the second most important component. The second most important component is nothing but it is called as text splitter. Now text splitter is also a separate class that is available in Langchain, or a separate package, wherein there are multiple ways of splitting the text. Once you read the data from all these kind of sources, right, I cannot just directly provide the entire data to my LLM model as a context, right? So what I have to do, why I cannot provide? Because there is a very important component which is called as context window. Every LLM has a limitation with respect to the context window. So in order to overcome this, what we do is that once we read the data from this data source, we try to divide this data into smaller chunks. Once we divide this data into smaller chunks, then the next step, because after we divide this, we need to store it somewhere, right? And that is where your third important component comes, is nothing but vector databases. Now, inside this vector databases, when we are specifically using vector databases, here we also use something called as vector embeddings. Now, for vector embeddings, it is nothing but we are converting the text into vectors. That is the main aim with respect to vector embeddings, right? So this is the kind of a task wherein we convert the text into vectors. So once it is basically converted, we basically store that into the vector database. Now the question arises, why do we store it, right? Because at the end of the day, from any application, if all my data is basically stored in the vector database, we will definitely be able to do different kind of search. One search example is nothing but semantic search. It can be GraphDB search, right? And with the help of this search, we will be able to retrieve the right amount of context and give it to our LLM to finally generate the output, right? And that is really important, right? Unless and until this is not done accurately and we don't get the right kind of context out of the vector database, we will not be able to accurately give the output to the user, right? So in the retrieve component of Langchain, you really need to be good at all the specific things. When you go tomorrow to any companies to generate, and if you're probably generating or developing a generative AI powered application, you will be doing all the specific steps. You need to parse the data. You need to probably store the data in the exact right format with respect to the document data type. You need to make sure that you have to do this kind of chunking strategy so that you try to solve this context window size with respect to different LLMs that you're using. And finally, you store all this particular data into the vector database. Okay. Now coming to the next important step, after we probably complete this retrieve component, it is nothing but summarize. Now here is where, and when we talk about summarize or when we talk about building generative AI applications with the help of Langchain, here you specifically follow a sequential order. Okay, this is very important to understand, and here you will definitely be understanding the differences between Langchain and LangGraph. When we talk about sequential order, now what does this basically mean? In sequential order, here it basically means that the execution of any task will just happen sequentially. We cannot go back. Okay, so this entire Langchain, the generative AI application that is developed with the help of Langchain, follows a DAG graph, right? Directed acyclic graph. Okay, that basically means my execution is basically started from this task. It has to probably go to this task. It has to go to this particular task. Only sequential. I cannot come back. This option is not there. This option is not there, right? So when we talk about this summarized comp, cannot come periodic. Now this is very important to understand, and here you will definitely be changed. Here you specifically follow a sequential order. Talk about after we probably complete this retrieve component. It is nothing but summarize. Now here is where And when we talk about summarize or when we talk about building generative AI applications with the help of Langchain, here you specifically follow a sequential order. Okay, this is very important to understand. And here you will definitely be understanding the differences between Langchain and LangGraph. When we talk about sequential order, now what does this basically mean? In sequential order, here it basically means that the execution of any task will just happen sequentially. We cannot go back. Okay, so this entire Langchain, the generative AI application that is developed with the help of Langchain, follows a DAG graph, right? Directed acyclic graph. Okay, that basically means my execution is basically started from this task. It has to probably go to this task. It has to go to this particular task. Only sequential. I cannot come back. This option is not there. This option is not there, right? So when we talk about this summarized component, here you'll be able to see that we create some kind of chaining concept. So in Langchain, whenever generative AI application is basically developed, here we try to implement this chaining concept. Now in the chaining concept, we first of all go ahead and write our prompt chain. So let's say this is my prompt chain. Right, so this is my prompt. We basically go ahead and give a prompt. Prompt is just like an instruction to an LLM, right? Along with this, we try to integrate this prompt with our LLM. So LLM will be my second thing in the chain, right? Second important component in the chain. And then the third important component can be my context, the context that I'm supplying to the LLM. So this will basically be my prompt. This will be my LLM. And this will basically be my context. And this context will be coming from the specific vector database. So internally, you'll be able to see that this vector database will be connected to this particular chain itself, wherein we will be providing the context. And this execution takes place sequentially, one after the other, right? And finally, whatever output you basically get, here we are basically going to use, or here we are going to get the answer output. Here again, we can use multiple components. One component can be my memory, right? So here we can use some kind of persistent memory. So if you have been seeing my videos with respect to Langchain or LangGraph, I've covered all this specific thing, right? And next thing, after this persisting memory, I can also go ahead and probably combine prompt with a separate LLM over here. Prompt with a separate LLM over here, so that we will be able to get the output, right? And finally, here you can actually see that finally we just will be connected. So that LLM, so LLM AI application is basically developed. Here we create from this task. It has to probably go to this task. It has to go to this particular task. Only sequential. I cannot come back. This option is not there. This option is not there, right? So when we talk about this summarized component, here you'll be able to see that we create some kind of chaining concept. So in Langchain, whenever generative AI application is basically developed, here we try to implement this chaining concept. Now in the chaining concept, we first of all go ahead and write our prompt chain. So let's say this is my prompt chain. Right, so this is my prompt. We basically go ahead and give a prompt. Prompt is just like an instruction to an LLM, right? Along with this, we try to integrate this prompt with our LLM. So LLM will be my second thing in the chain, second important component in the chain. And then the third important component can be my context, the context that I'm supplying to the LLM. So this will basically be my prompt. This will be my LLM. And this will basically be my context. And this context will be coming from the specific vector database. So internally, you'll be able to see that this vector database will be connected to this particular chain itself, wherein we will be providing the context. And this execution takes place sequentially, one after the other, right? And finally, whatever output you basically get, here we are basically going to use, or here we are going to get the answer output. Here again, we can use multiple components. One component can be my memory, right? So here we can use some kind of persistent memory. So if you have been seeing my videos with respect to Langchain or LangGraph, I've covered all this specific thing, right? And next thing, after this persisting memory, I can also go ahead and probably combine prompt with a separate LLM over here. Prompt with a separate LLM over here, so that we will be able to get the output, right? And finally, here you can actually see that finally we generate this specific output. So this can also be created in the form of chain. But understand one thing. Everything is basically getting executed sequentially. This is the most important thing in the entire Langchain with respect to developing any generative AI powered applications. Okay, so here is what we basically do with the help of Langchain, right? And again, I will again talk about the differences as we go ahead. Like what are the main exact differences and all. Here you saw that it is following a sequential order. It follows a directed acyclic graph. Here everything is in the form of chaining. Here we have these three important components. How each and every component is basically executed and how it proceeds to finally getting an output, right? Now similarly, if I talk about LangGraph, okay, LangGraph. Now when I talk about LangGraph, here the main aim is basically to create stateful, multi AI agentic application or AI agents, stateful multi-AI agents itself, right? Now, here, the main aim, if I just want to probably break this down, here you'll be able to see that we create AI agents, and it's not like a single AI agent. It'll be multiple AI agents which will be doing separately different tasks. And the best part about these AI agents is that they can communicate with each other to solve a complex workflow. I've already started my entire LangGraph playlist, and I think if you're following them, I've explained this entirely in a much more detailed manner, in the live classes that I've actually taken in my YouTube channel, right? Now, here, the main thing is that it need not be directed or cyclic graph. It even need not be sequential. This can follow in a different way. Okay, so first of all, we'll talk about what are the important components in LangGraph. Okay, some of the important components in LangGraph are like tasks. Second important component we basically use as nodes. Third, it will be something called as edges. Fourth is nothing but graph. So that basically means my entire LangGraph, the complex workflow that is defined, it will be in the form of a graph. And when you see a graph, right, if you probably have some knowledge about graphs, let's say here, I'll just go ahead and write, this is my task A. Okay, this is my task A, right? So let's say this is my task A. This can be my task B. This can be my task C. This can be my task D. And this can be my final task, that is end. Let's say. Now, each and every task over here. So let's say if this is my task A, this is my task B, this is my task C, this is my task D. So when we talk about this kind of task, we basically start over here, there'll be a conditional edge, then we go to task D, then finally we go to end. Now here also I'm showing sequential only, but one important thing is that you can go back from task B to task A, you can go back to task D to task C. You can re-execute this and here you can come. So that is the reason why I'm saying that this two important thing is basically happening. That is communication within this particular task, and each and every task is executed by a separate AI agent. You can basically create a separate AI agent and perform the task similarly. And the output of one task can be passed to the output of the other task. It can also be vice versa. Right? So here, a feedback mechanism can also be generated, and even human feedback mechanism can also be included. So this way, you are able to solve a very complex workflow. In my recent live session, I gave a hackathon wherein you have to probably implement the entire software development lifecycle with the help of human feedback, with the help of this entire complex workflow. So what is software development lifecycle? First, requirement gathering, then business understanding, then documentation, then code creation, then unit testing, then managers probably reviewing the peers reviewing the code review, providing the feedback, quality check, all those kind of check, and finally implementing the entire software development lifecycle. And people implement it in a much more beautiful way. So here, if you probably see, we follow an entire graph structure, and this graph structure need not be a directed or cyclic graph, because here my task can go from up and down, it can go here and there, right? So if you see some of the important differences with respect to the component, here we use components like prompt, LLM, context, we use data ingestion, we use persistent memory, right? Here we specifically use nodes, edges. So these are nothing but these are nodes, right? These are edges. Edges is basically used for flow of information. And when I say stateful, here the persistent memory is quite more efficient. And the best part about this is that the memory is basically shared between each and every task. Any update that I'm doing in one variable, this all nodes will be able to access those variables. And persistent memory is quite efficient in LangGraph, right? So if I talk about agentic AI application, you may use some of the components that are available in the Langchain, but at the end of the day, you are building an amazing agentic AI application with the help of LangGraph, right? Other than that, there are some more differences which you can probably find out over here. So these are some of the important components. As I said, with respect to persistent memory, this is much more efficient. Here we just use a sequential order. Here it did not be a sequential order to solve any kind of use cases, right? And here we also understood what are the important components, and here what are the important components, right? Now, the reason of making this specific video is to make your understanding very, very strong. If I ask you a question, hey, when should we probably go ahead and use fine-tuning? Or when should we use RAG? Or when should we probably go ahead and use, let's say, prompt engineering? Many people are not able to clearly see the differences, right? If this is the kind of question, I've already made this kind of videos. This video is actually in the companies now. Many people, more than 80 to 90% of the people in the companies are implementing efficient RAG systems. So here also you'll be able to see that when we create, these are like traditional RAGs. Okay, I'll also talk about traditional RAG and agentic RAG. So in the traditional RAG, you basically create an LLM, right? Let's say this is my LLM powered AI application. This will be interacting with my RAG database. Right, so this will basically be my RAG database, and this RAG database will provide the context to the LLM to finally provide the output. Right here, if my input is basically going on. So this is what is basically happening in a traditional RAG. In the case of agentic RAG, we create agents. We create AI agents. And this agent is responsible whether I have to make a call to my database, whether I have to make a call to my tools, or whether I have to take any kind of other action. Automatically, this AI agent will be able to take that particular decision and provide me the response. And then probably, let's say that after getting this information, I don't need to go and hit the tool and provide to get the response. This entire thing is basically implemented in the form of a workflow, right? So this is how things basically happen. I'm soon going to make a detailed video on different types of RAG, which is one of the most important component that is currently required right now. Okay, so I hope you like this particular video. And this was the basic differences between Langchain and LangGraph. In the upcoming videos, I'm also going to discuss about other frameworks, like say Clue AI, Hackno, and I'm going to probably go ahead and explain you all the specific things. And these are all things we detailedly explain in our live batches. All the information will be given in the basic differences between Langchain and LangGraph. In the upcoming videos, I'm also going to discuss.
What are the live courses? Definitely they will be costly. So what is the price? Fee, I mean. Oh God, how much money they are earning. They have created so many courses, live courses and all. Definitely they are working hard, bro. But, but from Udemy, I think they are making multi-crores, big amount. Just checking. See, 6,500. Good coding knowledge. This. I don't have many. So sad. Okay, so here traditional data science first, modern generative AI first, modern route, then code, no code, code master, Gen AI LLM. What the heck? They build pretty cool things. What is free have? Complete data science. Okay, decrypt the sources properly. I'm the duffer. Okay. Hmm. I think I should I stop. I will start Langraph from tomorrow. Thanks. Bye bye. And see you soon. Take care. What I'm blessing you or what? Hey, thanks. Thanks.